Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 2182, construct string with repeat limit. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking that you need to make the lexicographically largest string from the given string. For example, if you are given a string like this, and using the character given, you have to make the largest lexicographical string. But there is one condition, that you can repeat certain character at most 2 times in a row. What do I mean? For example, there are 4 A's and 3 B's in this string. So if the repeat limit is equal to 2, then we can, let me scroll a bit, then we can repeat 2a at most in a row. After that we can use b, then we can repeat 2a and then b. We can do something like this. We cannot do 3 a's together. So I hope this much is clear. So if we want to make the lexicographically largest, so we have to take the largest character at the first. So here among a and b is the largest, so we take 2 b's together, and we cannot take third b because limit is 2. So we will take 1a and then again a b and then again a 2a. So 1a is left, and also there is written nowhere that we have to use all. It is just written that we have to return the lexicographically largest, and also it should be longer string if 2 string are equal. You can read this. So it should be the longest. So this one is the lexicographical largest string possible. So how we get lexicographical lexicographical string is use larger character at front. By larger I mean b is greater than a. Instead of larger we can use greater. B is greater than a, C is greater than B. That's how. And also maximize its length. And one note, and doesn't mean that we have to use all character in the string. This is clear. This is what we have to do. We have to make a lexicographical largest string. So what is very first thing that we need? The greatest among all present in the string. Why? Because we need lexicographically largest, so we have to use greater character at the front or larger character at the front. So what we have to do is larger character at the front. And also we have to check the condition of, what was that name, repeat limit. We cannot change that limit. We have to obey this. We can only repeat these many character in a row. So that's a thing. So So we need larger character at the front, and we need to obey this also. We need both the things. And also third thing is it should be the longest. So how we get these large characters? What is the most easy way to do it? Which data structure that we should use? Which data structure? I suppose priority queue. Priority queue. MaxHeap type. Why priority queue? Because it is easy to get large character without using much brain, because at the top you will always have the large character. Then only thing will left to handle is this repeat length, because in order to make the lexicographically largest we have to make use of largest character at the front. And as you can see we have duplicate, so that's why we have to check this condition. And when this condition happens, what we have to do? Take next frequent character and just use that character. And again do the same thing. Again do the same thing. The previous character that we were using. What I'm saying is, let's take example. In the previous example we were given 4 A's and B 3 B's, and our repeating limit was 2. So we have to take 2 B's. Then what we do? We take 1 A, then again repeat, because this is much greater lexicographically than this. If we do this, as you can see, it will much better than this. Length is only compared when you have same lexicographical thing. So this is our plan. We will try to repeat the largest character till the limit, and then what we will introduce a next frequent, and then again we will use the largest, and after that second largest, then we will use third largest to counter that limit. That this is how it goes. So what we are doing is we are using greatest character, and then to counter that limiting condition we use something else in between. Then again this is how it goes. So what we are doing, we are just inserting in between the greatest to counter that. What to counter? This repeat limit. I hope this much is clear. So our algo would look like this. Let me summarize. What we will do is, first calculate the frequency using an ordered map. It is a no-brainer kind of thing how we are going to get this frequency using an ordered map. And what to do now? Declare a priority queue. Which would look like this. Character comma int. Why this? This is the character and its frequency. This type of priority queue we will be using. And what we will do in third step, take the greatest character till limit, and till limit, there are two conditions that can happen. For example, if you have limiting condition 3, and let's take example, you are given a3 b2 and limiting condition is 3. So we are left with nothing. And there can be a case like this, the case that we discussed. We will leave something 1b. So there are two conditions that we have to handle. This one and this one. This is normal, we don't have to do anything. This one is not normal, we have to do something, because we will have two b's, then we have one a. In this there is no such thing. We will have two b's then 2a. There we will have thing. So we will just insert till limit and we will check if this count, this whatever the frequency, if it is still greater than 0, what we will do is, what we have to do, pop again second frequent, my bad, the next largest. Pop, we will pop, and what will be popped? The next largest, lexicographically largest. So what we will do is, we will just use it one time, and then if it is still greater than 0, we will again push it inside the PQ, and after that what to do, we will, if this is not fourth, if, and what we will do, if this we are in this block only, what we will do after this, we again push the remaining. What do I mean by remaining? For example, we popped this b, we used two b's, and after that we popped this a, we used one a, then we again pushed it. What we pushed? A comma 2, and we have left b comma 1, so we again push it, because we have to use it again. After b a, we have to use b, because in order to get the largest lexicographical string. That's it. That's what we are going to do. We'll make a map to count the frequency, then we will fill this priority queue. Priority queue will look something like this, and what we will do, we'll take the greatest lexicographically, we'll keep on adding in the string, as we have to return a string, till the limit. If the frequency of that greatest is still not 0 after the limit, what we have to do, take the second largest lexicographically, and what we do, we just use its one frequency, and if it is still greater than 0, what we do, we just push it back, same as a comma 2. Previously a comma 3, now it's a comma 2, because we used 1a. And after that, when we pushed, we will again push the remaining. What I mean by remaining is the b. As you can see, one b was left, b comma 1, so we have to again push it in order to get this b a comma b. So this much is clear. Let's see the coding part, and I will dry run that only, that code, in order to make you understand more this algorithm and the code flow. So yeah, this is the ordered map, taking the frequency, declaring the priority queue, filling the priority queue. This is the answer string, and what we are doing, iterating over the priority queue, what we get? The largest, lexicographically largest present in the string. Pop it. And what we do? We keep on adding till the limit. And if we check, here is our count. Here is our count. As you can see, we get the over here. Over there, I was saying frequency. I just declared count over here. And we have count. And also you can see the limit. And we will check if the count is greater than 0. And PQ size is still greater than 0. What it means is that it can be the last one. So there is no need. Why I am saying, as you can see, if something like this happen, we were having 3 B's and 1 A. Five B's, 6. After this, let me check priority queue size. What this case is, A, B, B. And when we again go inside, what we still have? Nothing. If we were have 1A and B4, we use 2 B's, then A, then again B. We cannot use third B. If there was 5 B's, we cannot use third B. And this is also 0. And this is also popped, as priority queue is empty. Do we have something else that can be put in between? Do we have something else? No. In that case, that is our end. So that's what I am doing over here, not over here, over there. That if it was the last one, then there is nothing we can do. Something has to be in the priority queue so that it can be filled in this gap. Yeah, so we are getting the second character and the second count, the frequency. Pop it. We use only one time frequency is decreased, and we'll check if it is still greater than 0. What we'll do, just push it. Now also what we do, the left, the count one character, the lexicographically largest count was still left, so that's why we have to insert it. And let me do it over here. What we are doing in this case, B, A. B were 3 and A are 2, for example. So we inserted a A, and what was left is 1B. So we have to again insert it in order to get this. So that's, I already discussed it. This is how it's working, and let's dry run it to understand even further, to have a better understanding. Yeah, let's take this part, important one. This is the test case. Let's copy it and paste it over here. Yeah, this is the test case. So what we will be having is 4A, 3B, and this will be inside the priority queue, A, 4 and B, I just did mistake, B, 3 b comma 3, a comma 4. So yeah, we just pop b comma 3 is popped, and what we do, limit is given 2, so we insert it, string. I am writing string over here, so we inserted 2 b's and 1 b is left, b comma 1 is left, and we get out of the loop and count is still greater than 0. Let me write over here is ch was b and count was 3. Now count is 1. Count is still greater than 0, and we have something inside the priority queue. Why? Because we need to insert something in between, so we pop it again. Second ch is a, and that count is second count is 4, and we just decrease it 1. We use a over here and we check if it is still greater than 0, and we can see it is still, so we'll again push it inside the priority queue, a comma 3, and also this b comma 1 is pushed. Now again we do the same thing, we check the limit condition. As you can see, we have and over here, and count will not be greater than 0 when we use that b, and because of that we will just get out of the loop, and this will not be executed because count should be greater than 0. Count should be, but count is 0 over here. As you can see, count is for b. Where is my pointer? Count is for b, so b is 0. It is popped. Now in next iteration we will access a comma 3, and we will use 2a, and count here is 1, and what we will check, yeah, count is greater than 0, but priority queue, is it greater than 0? No, because it is the last one, and we have the limit of 2. We have nothing to insert here to get this, so what we do, we leave it and we will just return this as an answer. You can match it same. So I hope dry run was clear. Let's submit it and see if it is submitting or not. Yeah, it is submitting. I hope I was able to make my intuition clear, and if I was, so consider subscribing to the channel, liking this video and sharing with others. You have to do what you have to do, so keep grinding. You guys are awesome. See you in the next one. Bye bye.